Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 14 on Gases, Part 2, Section 2, 14.2 gas laws, and then this is video Part 2. Alright, so let's talk more about gases. The pressure increases by more frequent collisions of molecules with the container or harder collisions. So if there's more collisions, the pressure goes up. If there are collisions with harder force, with more force, more kinetic energy, then the pressure increases. So that makes intuitive sense. And why does that happen? You either increase the number of molecules so that there's just more collisions. You reduce the size of the container so that there is more collisions per area of the wall of the container, or you increase the temperature so that the collisions have a more kinetic energy, they have a higher force. So we're going to be looking at these relationships with gases and pressure and volume and temperature. So first one we're going to look at is called Boyle's Law. It is a pressure-volume relationship. And pressure and volume are inversely proportional, which means when one goes up, the other one goes down. So if I decrease the volume, I'm going to increase the pressure. The pressure is going to go up. So if I take my original volume and I decrease it, then there's going to be more pressure on the walls of this container than the original container. There's just less area. Okay, and then all of the other relationships would be true. You don't have to write these down because you could probably figure it out. You can write it down if it would help you. If you increase the volume, that means the pressure is going to go down. If you increase the pressure, keeping everything else constant, you would have to decrease the volume. And if you decrease the pressure, keeping everything else constant, you would have to increase the volume. All right, so we can talk about that in generalities, but we really want to dig into it, so let's get some numbers. Let's throw around some numbers. So the pressure and the volume equals K, some constant. So the pressure, the initial pressure and the initial volume have to equal the second pressure and the second volume, because we know PV equals K and K is constant. So one PV always has to equal another PV because they equal the same number. They both equal K. And then we know if pressure goes up, the volume's going to have to go down to keep this number constant. All right, so let's do an example. So please write this down. If a weather balloon is released on the ground with a volume of 3.0 cubic meters and a pressure of 1 atmosphere, how large will the weather balloon get when it reaches an altitude of 100,000 feet where the pressure is 0.0100 atms? Okay, well, we're always going to start by figuring out what we know and writing the equation. So let's do that. All right, so let's tackle this problem. So looking at our problem, we know pressure. So let's see. There's my pressure. And let me check my board for a second. So let's see if it's on the ground. That's going to be the initial pressure. And then we see another pressure, and that's going to be up in the air. So that's our second pressure. And let's look at our volume. All right, so that is the volume on the ground. So that's going to be our initial volume. And then how large will it get? V2 is our question mark. All right, so If you want to write down what you know, kind of have it nice and organized, that's a good idea. I have the equation written down. Let's sub in our numbers. So make sure you have P1 V1 equals P2 V2. And P1 is 1.00 ATM times our V1 is 3.0 meters cubed equals our P2 is 0.0100 ATM times our V2, which is our variable. Okay, so now what we're going to do is we times these two together. Well, we get, let's write that in black. We get 3.0 ATM times meters cubed equals, and then I'll write that in the blue still, 0.0100 ATM times our V2. Well, to solve for V2, we're going to divide each side by 1/100th, 0.0100 ATM over 0.0100 ATM. So the ATMs cancel. And we have 3 divided by 1/100th. So we're going to have 300 cubic meters equals our second velocity. Not velocity, our second volume. All right, so let's take a look and make sure that makes sense. So if it's about 1/100th of the pressure, we would think it would be about 100 times bigger. And it is. 300 cubic meters. Good job. Okay, when do you use this information? Every second of every day. Every time you breathe. So when you breathe in, your diaphragm contracts, which makes more volume, creates more space in your chest. So it increases the volume. And we know when you increase the volume, the pressure has to go down. So now you have low pressure in your lungs and a higher pressure outside. And things normally move from high to low pressure. So the air just moves from outside to inside. So you're not like sucking air in. The change in pressure is bringing air naturally into your lungs. So I think that's pretty fun. Okay, let's look at the relationship between temperature and volume in gases. And this is called Charles's law. So something you need to know is when we're dealing with gases and gas laws, we're always dealing with Kelvin. So you have to convert all of your temperatures to Kelvin. So 0 Kelvin is equal to negative 273 degrees Celsius. So we have to convert all our temperatures to Kelvin when using gas laws. So basically adding 273 to all of our Celsius temperatures. All right, so volume and temperature are directly related. So if you increase the temperature, you increase the volume. If you decrease the temperature, you decrease the volume. So let's look at a scenario where I took my balloon and I put it in the freezer. What's going to happen to it? Well, the temperature is going to go down in the freezer, so it's going to get smaller. And the converse is also true. If you increase the volume without changing anything else, you have to increase the temperature. If you decrease the volume without changing anything else, the temperature is going to decrease. So your volume divided by the temperature is always this K, little k, not Kelvin, but a constant. So your initial volume divided by your initial temperature will always equal your second volume divided by your second temperature, because this equals K and that equals K, so they equal each other. All right, please write down your problem. If you inflate a balloon to a size of 8.0 liters inside at a temperature of 23 degrees Celsius, then you go outside and the temperature is 3 degrees Celsius, what will be the new size of the balloon? Okay, let's tackle this problem. So first thing we should do is we should write down what we know. Let's give ourselves lots of room to work. So we know our volume, our V1, equals 8.0 liters. What will be the new size of the balloon? That's going to be our V2. Okay, we also know our initial temperature is 23 degrees and our second temperature is 3 degrees. So T1 equals 23 degrees Celsius, and let's just go ahead and do our calculation now. Plus 273 equals what in Kelvin? 296 K. And our T2 equals 3 degrees Celsius. Let's go ahead and do our conversion as well. Plus 273 equals 276 Kelvin. All right, the next thing we do is we write our equation. So let's give ourselves lots of room. V1 over T1 equals V2 over T2. So our initial volume is 8.0 liters over let's say 296 Kelvin. And then our second volume, well, that's our variable, and over our second temperature, which is 276 Kelvin. Well, we're trying to solve for V2 in this scenario, so we're going to times 276 Kelvin on each side. So then we're going to simplify on the left. And on the right, that's easy, they cancel out, we're just left with our variable. So unless you can do that in your head, you want to grab out your calculator. Okay, I'm going to take 8 and divide it by 296. I'm going to times that by 276, and I get 7.459. So 2 sig figs, I get 7.5. And then it's volume, so it will be liters. And let's double check that that makes sense. So I went from 23 to 3, so I'm decreasing in temperature, and there's a direct relationship between volume and temperature. So if my temperature goes down, my volume should go down. Did my volume go down from 8 to 7.5? It did. Good job. Okay, in our next video, we're going to put Boyle's law and we're going to combine it with Charles's law to form a combined gas law for PV divided by T. So we've got P times V and we've got V divided by T all together. So I will see you in the next video. Bye.